Welcome to Understand the Math. In this problem, we're going to determine whether the following set of vectors is orthogonal. If the set is orthogonal, we're then going to normalize the vectors to produce an orthonormal set. We're going to begin this problem by labeling the three vectors that we've been given, and I'm going to choose to label these vectors v1, v2, and then v3. If our vectors are orthogonal, what's going to happen is their dot products are going to be equal to 0. So v1 dotted with v2 is going to be 0. v1 dotted with v3 will be 0. And then lastly, v2 dotted with v3 will also be 0. So that's what we have to check. So let's start by taking v1 and dotting it with v2. To take the dot product, we're just going to multiply the corresponding components. So we're going to multiply minus 2 times 1 and get a minus 2, and then a 1 times 2 gives us a 2, and then a 1 times 0 gives us a 0. So this is indeed 0. Now let's check the dot product of v1 with v3. Multiplying those components, we get a minus 2 times a minus 2, which is a 4, and then a 1 times a 1, which is a 1, and then lastly a 1 times a minus 5, which gives us minus 5, and we add all this up, and that's also equal to 0. Let's check our last one. We're going to take v2, and we're going to dot it with v3. So this is going to give us a minus 2 plus 2 plus 0, and that is equal to 0. So we can conclude, because all three dot products are 0, that our set is orthogonal. Now what we need to do, since our set is orthogonal, is to make our set an orthonormal set. I'm going to call our orthonormal set vectors u1, u2, and u3. When a set of vectors is orthonormal, the vectors are orthogonal, and the vectors also have a length equal to 1. So we're going to let u1 be v1 divided by the magnitude of v1, because dividing a vector by its length gives it a length of 1. And then we're going to write down a similar formula for u2 and then u3. We're going to begin by finding the magnitude of v1. So the magnitude of v1 is just going to be the square root of each of the components of v1 squared. So that's going to be a minus 2 squared plus a 1 squared plus a 1 squared, and this is equal to the square root of 6. Let's go ahead and compute the magnitude of v2. We'll have to look back up. That's going to be a 1, a 2, and a 0. So we have the square root of 1 squared plus 2 squared plus 0. And this is going to be equal to the square root of 5. And then our last one, the magnitude of v3. Again, let's look back up. We have a minus 2, a 1, and a minus 5. This is the square root of minus 2 squared plus 1 squared plus a minus 5 squared. And we'll extend our square root. So this is going to give us a 4 plus 1 plus a 25, and that's the square root of 30. Now let's go ahead and write down our vectors u1, u2, u3 that form our orthonormal set. Our u1 is just going to be our vector u1 divided by root 6. So we have a minus 2, 1, 1. So minus 2 over root 6. 1 over root 6, and 1 over root 6. And then our u2, We're going to have to divide every component by root 5. So that's a 1, 2, 0. So we have a 1 over root 5, a 2 over root 5, and then a 0. And then lastly, our U3. These ones are a little bit harder to remember. Minus 2, 1, minus 5. So we have a minus 2 over root 30, a 1 over root 30, and then a minus 5 over root 30. Our orthonormal set of vectors, they all have a magnitude of 1, and they are all orthogonal to each other.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.